Hi, my name is Janice, and in this video, I will be walking through how to solve the following problem. As stated here, the question asks us to choose a stronger acid from each pair and be sure to support our answer. In order to solve this problem, we need to know the three factors that affect acid strength. The three factors we'll be covering that affect acid strength are bond polarity and bond strength, the presence of oxygen, and electronegativity. So first, I'll be talking about bond polarity and bond strength. The more polar the HA bond is, the weaker the acid is. And the weaker the HA bond is, the stronger the acid is. So if A is more electronegative than hydrogen, more electrons are being pulled towards A, which means the polarity of the bond increases. And as the polarity of the bond increases, the acid strength increases. Making it easier to donate a proton. So that's why the acid strength increases. And for bond strength, the weaker the bond is, the more easily a proton can be donated. Thus, a decrease in bond strength means an increase in acid strength. So now we can look at how the presence of oxygen affects acid strength. Oxy acids typically have a formula of Hy, in which this is hydrogen, and the electronegative element is bonded to the oxygen. So the more oxygen is present in an anion, the stronger the acid is. And another way we can look at this is with the oxidation state of the central atom. So as the oxidation state of the oxidation number of the central atom increases, the stronger the acid is. So for A and B in this problem, we have sulfurous acid and sulfuric acid, and we can apply the second factor to this. So we can see that sulfurous acid has less oxygen than sulfuric acid, so therefore we can conclude that sulfuric acid is the stronger acid in this pair. But we can also look at the oxidation state of these acids to see which is stronger. So for sulfurous acid, the charge on the oxygen is -2, so we know that is -6, and there are 2 hydrogens, so it's +2. Therefore, the oxidation state of sulfur has to be +4. And for sulfuric acid, we do the same thing, where this is -8 +2, and sulfur has to be +6. And we see the oxidation number of sulfuric acid is higher than in sulfurous acid. So again, sulfuric acid is a stronger acid than sulfurous acid. And for B, we can say the same thing, where there are 3 more oxygens in here in HClO3 than HClO. So this is a stronger acid. Next, we can talk about electronegativity. So as electronegativity of the element increases, the element is able to pull more electrons away, which increases the polarity, making it easier to donate protons. And therefore, as electronegativity of an element increases, the acid strength increases. And we can apply this to part C, where if we look on the periodic table, chlorine is more electronegative than bromine. So based on the electronegativity trends, HClO is a stronger acid than HBrO. For the last problem D, we know that acetic acid is a weak acid because it's not one of the 6 strong acids. And sodium acetate is a strong base salt, therefore acetic acid is stronger. A way to show that sodium acetate is basic is by writing a balanced equilibrium equation for each interaction of the ions in water. So for sodium acetate, we can split it up to be CH3COO minus plus water, and we write the bidirectional arrows OH minus plus CH3COOH. And for the sodium ion, we put Na plus water, and we get NaOH plus H plus, which this is a strong base, and this is a strong acid, and so it turns out the pH to be 7, and it's a neutral solution. And for the top equation, this is a basic solution, therefore it is overall basic. And so acetic acid is a weak acid and sodium acetate is a strong base salt, therefore acetic acid is stronger. So overall, we were asked to pick the stronger acid using what we know about the factors that affect acid strength, and we figured out which acid is stronger for each pair.